Okay, so let's take our example based on our discussion. The first step mentioned is to create a ground which is already created in our example. So this will be our reference node. Okay, after that is that we would, okay, analyze the system by, of course, pointing the different nodes. So we have our node A and our node B as my reference node, or my node 1 and my node 2. So now after that is that we would create our assumptions of the direction of current. Let's say this will be my I12 coming from V1 going to 2. This will be my I10, and this will be my I20, or from V1 to 0, or to the reference node, and V2 to the reference node. Now after that we can now create our equation. So if I would take my KCL at node 1, so if I would take my KCL at node 1, you can see that the currents entering to my node 1 is my 5 ampere, and the currents going out my node 1 is my I12 and my I10, which is equal to 0. But what is my I12? My I12 is, of course, the voltage from V1 minus V2 divided by the resistance 4, and my I10 is equal to V1 minus the lowest potential 0 all over my resistor 2 ohm. So from here I will have my 5 is equal to my I12, which is equal to I minus, I should say. So I 5 minus my I12, which is equal to V1 minus V2 all over 4 minus V1 all over 2 is equal to 0. So from here I have 5 minus V1 over 4 plus V2 all over 4 minus V1 all over 2 equals 0. By further simplification of the equation, so let's solve, or let's add for the like terms. Okay, so I have 5 minus V1 over 4 plus V1 over 2 plus V2 over 4 equals 0. So from this I have 1/4 plus 1/2, which is equal to 3/4. So 5 minus 3/4 V1 plus V2 over 4 equals 0, or by further simplification of this equation I have negative 3/4 V1 plus V2 all over 4 is equal to negative 5. This can be our, or this will be our equation 1. Next is that we can take our KCL at node 2. So KCL at node 2. So this is our node 2. So what are the currents entering and going out our node 2? So as you can see, our 5 ampere is going out our node 2, therefore I may create this as negative 5 ampere, and my 10 ampere is going into my node 2, therefore I can write this as positive 10 ampere, and my I12 from the direction of it is going to my node 2, which is I12, and my I20 is going out the node, so therefore I may write this as my I20. Now I have already I12 and I20 is not yet found in my equation. So therefore my I20 can be written as V2 all over 6 from V2 minus 0, which can be written as V2 all over 6. So from that, I have negative 5 plus 10 is positive 5, right? So plus my I12, which is equal to V1 minus V2 all over 2 all over 4 minus my I20, which is equal to negative minus V2 all over 6. So from here I have 5 plus V1 over 4 minus V2 all over 4 minus V2 all over 6, or I can write this as 5 plus V1 all over 4 minus 1/4 plus 1/6 V2. So 1/4 plus 1/6, I have 5 over 12. So 5 plus V1 all over 4 minus 5 all over 12 V2 is equal to 0, or V1 all over 4 minus 5 over 12 V2 is equal to negative 5. So from that, I can compute it using my calculator. Okay, so finding two terms, or you can solve this manually, but of course we are already in modern day, so therefore we can create, or we can use our calculator. So negative 3/4 equals 1/4 equals negative 5 equals, okay, so negative 5 equals 1/4 equals negative 5 over 12 equals negative 5 equals. So therefore we have V1 will be equal to 13.33 volts and V2 will be equal to 20 volts. Okay, so that is our equation.